That no longer exists. But solid state, people tell me all the time, solid state, why should I take your class if solid state is the way everything's going to go? Why should we care about hard drives? Like, so the cloud is someone else's computer, and that has a hard drive. It does not have solid state. So I know you think hard drives are gone, but what happened is you have a band-aid over here to keep you alive while your data exists over there. And so you've just hidden it from your view. But that's still all hard drives. So, because you can't store data long term. And hard drives aren't meant to store data unless they're alive for more than 5 years either. So that's the other thing. So long-term storage doesn't really exist. Yeah, I mean, what are we going to do? I mean, like if you've got something 20, 30 years old that's really hard to bring it forward if you didn't copy it somewhere or do something with it. Your CDRs died, they oxidize, it's not oxidation, it's ultraviolet rays basically will slowly eat them, and they will slowly deteriorate because they're organic material. CDRs are organic material. That it's a dye that comes from a plant. That's primarily what it's made from. So most of them. So, all right. So now the whole point at this point in time in this process that we've been going through is for you to get a good feel. I didn't really expect necessarily when I designed the class for people to be successful in the first day or two. The whole point was meant to be it's as hard as it can possibly be. We've done horrible things to the drives. We've done worse than we would ever do in the real world in a recovery scenario because I've made you completely disassemble the drive down to bare metal. You would never do that in a real data recovery scenario. In a real data recovery scenario, you're looking at, well, if my platters are working, motor and everything else is intact, I'm only going to move the heads, and that will become easier to you now that you've done the harder stuff. If that had been what you started with, it would seem hard, but since you've done it all and you've had to play with platters and try to get them realigned, then that becomes the hardest part of it. Now it becomes easier from here. All the way till you get to 2.5-inch drives. 2.5-inch drives are super tolerant of changes. So you can pull platters in and out and change heads, and they typically will work. And most people get them the first try. Every once in a while there'll be something like, oh, this little tiny piece and I didn't realize that piece was there and I snapped something off. But other than those kind of things, you won't have that problem. It'll be very easy by the time you get to 2.5-inch drives. 2.5-inch drives are still expensive, even for small ones. Like I can buy surplus 3.5-inch drives all day long, and it's $500 for a box or whatever. But 2.5-inch drives, I mean, they still want $10, $20 per drive, even on the really old, tiny ones. So we still end up in a scenario where going through 100 drives is super expensive. But again, very tolerant, easier to do, not nearly as hard at all. It's all the 3.5s that were never meant to be moved, and nothing else happened. So you're supposed to get this feel for how hard this job is and why you get to charge $1,000, $2,000 to do a recovery and go through the entire process of trying to rebuild these now. Obviously, you guys don't get to charge money, maybe necessarily. So, at this point in time, we've also discovered that if you rebuilt a drive, you probably didn't get 100% of the drive copied every time that you've played with it. Now, it will get better if you only do heads. So if you're in a spot where you're only pulling heads out and putting heads back in, and you're not messing with the platters at all, your reading process will become better. You will get more sectors, you will have less problems, you may still miss a few. But it's definitely going to be some problems with the data that you've now recovered that you cannot get 100% of it, and you may have to either know what it looks like or manually rebuild part of it or combine 2 or 3 efforts together. So you may be doing an operating system scan of the actual MFT entries or the HFS entries or anything else, build that part, and then you may go back and cover anything you didn't get with that part with carving and try to reassemble files and trying to get where it comes from. Then you may add a third process in, like if you're dealing with photos and pictures and videos, they may have, really the whole point came down to the fact of years ago when people made JPEGs and graphics and cameras and video, that the operating system and the file system were not kind to the naming conventions and the time conventions and things that were built into the videos, and people wanted more information, so they created ways of repositing that data inside the videos. and the pictures. So you have EXIF information inside of graphics and pictures and things like that. And those things sometimes will have the file name and the dates and the times of all the original things that have happened. And so you can extract that data and replace the operating system data with that by using tools to do that. So you may end up in a situation where you've got a photo library and maybe it's not obvious all the names and the items that that person wants, and it may not be as well organized as say the iPhoto library would be, but you could convert the names back to the camera's names that took the pictures in the first place and extract the dates and times and reorganize the data in the file system by dates and times. So there are extraction tools to do that. And then later on, Microsoft finally gave it some thought, and then they added in those fields. Too late. It's kind of way too late at that point. But when exFAT came out, they added in the extra fields that you would have used for camera, video, GPS. exFAT is one of the only ones that has a location to store GPS coordinates in. So if you wanted to extract the GPS coordinates from a photo and build a directory structure with them, exFAT's the way to go. exFAT actually has a table that includes that in their content. They're not displayed in the file manager by default. But there are a lot of little things like that that as you start to recover content, that you can use the metadata to make better choices about what to give to your client and represent your data better. And if it's an automatic batch process that you can do, then it makes it a lot easier to say all these pictures were all taken in China while you were on vacation, so here's your China pictures, and make a folder called China. And the client might not even know, maybe that was their original name of their folder was client, China vacation or something like that. Whereas if you gave them a pile of files that just said 00123.jpg, 00124.jpg, 00125.jpg, they may not be as kind about that because they have to look at every single thing and they don't know how to do that. Does that make sense? So that's kind of the logical side, but I want to hit from, and when I wrote this again, when I wrote this class, I wrote it from a business perspective. If you're going to run a data recovery company, how do you make money and survive? So I do have a couple of slides and I'll just hit them quick, but the first thing is that now on this list, I've showed this pretty much every day as we've gone through it, we're still in this circle right here. We're still dealing with, and we still have to go back and talk more about diagnostics and then repair the drive. But you're pretty comfortable at this point, I think now, here and here, which is I've got to pull heads out, platters out, fix something, maybe not deal a lot with firmware, but other than that, now the question is what's wrong with the drive? So now you've got to start going through this process. And the 4 manual things are always going to end up being, out of the 5 possible choices, is your board, your head, your media, your motor, and then you have firmware, which is the only thing I can't easily show you without having the proper tools to do that. So that's the PC3000 and PC3000 direction only. I think you've also decided if you got a PC3000, it's going to be very hard to learn, and even taking one of their classes is going to be non-resultant in anything helpful. That's the problem. They really don't have a good way to teach you. And ACE Labs themselves, as I understood it, had stopped doing classes unless they were either government organizations or corporations. So that was all they're doing. They're not doing like individual classes anymore. So a lot of what you're going to learn there is going to be the seat of your pants. So now we're going to bleed in from here into here somewhat. That's what we're going to start talking a little bit about, and then still talking about the hardware and how it affects everything here from a file system and operating system. So these are just my business tips for people when they started out and they start dealing with the data and they start doing something. The first thing is, if you're emotionally attached to a drive, you will make a bad choice, I promise you. And a lot of times, a lot of you, at least a portion of you guys, are all on cases, and they know if you're related to somebody, they won't let you work on the case. So if you're emotionally attached to something, it becomes a real problem. And you have to, if you may be forced into it because your mom's going to give you a hard drive or something like that, or my Uncle Joe died and I needed to recover pictures from a hard drive that he had after he died to use the pictures at the funeral. And so things like that become a problem, and you're in a hurry and you'll make bad choices. So I'm just promising you, you need to start thinking, what's the safest way for the data, not necessarily complying with the client's request. The only time I really think about what the client's request is, and they don't like it, I'll tell you that. Sometimes they don't like it, but I'm a stickler for safety of the data over expeditious processing just because the client thinks that everything should be fast. And it depends on what it is. If the client says, I have payroll due tomorrow at noon, if you don't get it to me, I've already figured out another way to do payroll, and by that time I'll never need your files again because I've already progressed someplace else and started the rebuild process, manually got somebody else to do it, something else happened. So that's like one of the only situations that technically it's something like that being fast and doing shortcuts might be effective so that I get paid. Or you're on an oil rig and it's going down and it's on fire and the fire suppression system's on the computer, and if you can get that going, maybe you can save BP's oil rig in the middle of anyway, so things like that happen and you may have to take shortcuts. One of the shortcuts I hate, but sometimes you got to do, is working on the original drive. And when I say work on the original drive, I mean somehow I've taken that original drive and I've got to plug it into a Windows machine and it's hobbling along and having a lot of trouble communicating, and it's the worst way to do it because once you touch something it may die, you may never see it again. And that's usually what happens with people in software before they get to this class in the first place. They have a hard drive, it's not working right, they went to a website, they downloaded some software, they plugged their hard drive into the machine, they run the software on it, the software builds a tree. While it was building a tree, it touched every sector on the hard drive. And while it touched every sector on the hard drive, it did not copy it. See the problem? If you're not copying it and you touch it, it may be the last time you ever see it. So the entire process for the Deep Throttle Atoll, the PC3000, is if you touched it, I made a copy of it so that that copy will exist even if your drive dies. So you still have something. At the end of building a tree in those data recovery packages, now you pick the files that you want, but it's too late, your drive is dead now. So you see the list, and maybe you can make a screenshot and tell the client what he lost. That's the best you got. I know what you used to have. Sorry, but you don't have it anymore. Right? And sometimes that's it. That's what you got. So don't be emotional about your drives. Don't be in a hurry. There's nothing quick about this process. Nothing at all. Take your time. And clients call and they kind of rush me all the time. Oh, if I throw more money at you, can you finish it by tomorrow? No, it's not about me. It's about the processing of this drive. How long is it going to take to copy it safely or do something? So again, unless it's something that's critical by a certain time and I'm not going to get paid and then it's over, well then there's no point. If it's somebody's pictures of grandma, they may want them now, but if grandma died, they still want them in 6 months. So if it takes me longer to get that data to them, they'll still be okay. I just need to, I'd rather have the source. So never ever move your hard drive from one thing to another if it comes up. This is a common thing that happens. Somebody mails me a box. The box, when it left them, they say, I plugged in the hard drive, it was clicking, this wasn't working. They'll actually describe that. They'll say it's clicking, and I know there's something wrong with it. They put it in a box, they FedEx it to me, I get it the next day, and we call it the FedEx freeze. This is a phenomenon that happens. So sometimes the drive never works after FedEx had it when it was a working drive, but sometimes after it was a dead drive and FedEx gets it, it works. And the reason is they take it up in a plane, it gets frozen in the air, temperature changes, pressure changes, lands, then the box gets to me and it works. I plug it in, I'm like, there's nothing wrong with it. If that's what happens to you, copy it as fast as possible because it will die again. Whatever happened over there is going to happen again. You may have gotten lucky that the image works, but the first time you plug it in is sometimes the only time it ever works again. As soon as it came live, then you said, oh, I don't have the space over here to plug it in. I need to move it over there, and you unplug it and you plug it in over there, you will kick yourself. So you need to always be prepared on whatever you're on to image that drive or copy it. Don't plug it into some test piece of crap somewhere where you're not going to do the actual recovery there because it's going to be the last time it comes on. Okay? I promise. There are days you kick yourself and that happens like, oh, damn it. I know he said to do that, and that's what's going to happen. So I always have all my systems. I don't hook it up to something unless it's ready to go for recovery. And if it happened to be you hooked up to your laptop and it's working, then you better get a network connection over to a server that's got enough space to drop that file on it, because that's what's going to happen. I'm not going to be doing anything else. The other thing is you don't want to be going around and doing multiple directories. If you had to do it live, you choose one directory at a time if you're going to copy. and you wait for it to finish before you tell it something else. Because once you tell it 2 or 3 or 4 folders to do, then your heads are, it's doing this already. And now you've got it doing 2 segments of that at the same time. And it will cause you a huge amount of problems. And it's even more obvious on solid state drives. Because on solid state drives, even though there's no head and it's doing that, you can see a performance decrease that's tremendous. So it actually does cause more damage in the process. But since drives that are damaged don't do the same thing twice, the other thing that happens is persistence. Because I'll tell you when you'll get the data recovery. It'll be 5 minutes after you already gave up. It'll be sometime, you'll be like, I'm tired of this crap, I'm going to lunch. And you come back and it's like, holy crap, it's working. Like, it's, the more persistent you are, the better your chance is at getting this. And by the time you've actually gotten to the point where you're just tired of it and you're sick of it, that's when it actually starts to get better. So, surprisingly. So, be very, very cautious about that. Always try more. And I'm really bad about that. Like, I actually have clients that'll like call me and be like, all right, you know, I'll give them updates. I have dates, I give them updates, but sometimes they'll be like, you're taking a really long time. You know, did I make the right choice sending it to you as opposed to somebody else? I'm like, listen, somebody else, they just would have already told you no. They would have tried your hard drive. They wouldn't have been able to recover it, and it's a money game to them. If they get 100 drives in and 85 of them are easy, they're not going to do the 15 hard ones. Yours is one of the 15 hard ones. I'm doing the 15 hard ones the hardest way possible. I'm being persistent. I'm working hard on your drive. If you want, I'll just tell you no, I can't recover it, and I'll send it back to you. But I am trying harder. I have an ethical problem with that, so I fight to get your drive and your data back. And so I've had that discussion with many people, so they send me all the hard stuff, and I fight for all the hard stuff. But it does happen, and especially for other forensics companies. Other forensics companies who get their hard drives that are dead, they'll send them to me because they know I'll take the care and make sure that it is possible to get it back. So be persistent. Time is never your friend for a lot of reasons. But space, never delete something you've already worked on. It may be the last time you ever see that data. So sometimes I see people do this. They start copying something, the drive gets full, or they're close to getting full, or it crashes, and then they'll say, oh, I'm just going to do it again. They'll delete the directory they just did and start over again. Like, no, keep that, call it pass 1. Then make another copy and call it pass 2. Get another hard drive if you have to. Go to the store. Drives are cheap. Get it. Do not delete something. Always have more copies. You can merge them together at the end. Again, I've got drives I've had pass up, you know, usually about 4 is about what I end up with. 4 passes, and then I merge the 4 together. Heat. Drives don't like to get hot. But the same is also true in both directions. There are some drives who run better hot, like the Fujitsu that I told you about. The Fujitsu, sometimes it will run better if it is heated up. And so I have done some tests where you turn on the oven at 200 degrees and you put your drive in for 10 minutes and then you take it out. Sometimes it actually works. It's surprising that if you've got an environmental problem, sometimes that solves some of the problems. You leave it in too long, stuff starts to melt, so you don't want to do that. And you're saying, you have both of those. So, and I'm lucky in my office, I actually have in my office a full kitchen, so I have an oven in the kitchen. So, anyway, so go both ways with regards to that. And then eBay. Don't piss people off on eBay. I know you like, I mean, because I've been pissed off sometimes. I always try to be nice. You sent me something, it didn't work. It's DOA. You said it was going to be fine when you sent it to me. I try to be friendly with them. But there's only a handful of guys selling the drives you need. And so there's a good list of like 8 guys, and in the data recovery group that I have, some of them will tell you about other people that run a spreadsheet and they keep track of stuff, but they charge you extra money just to go look at the list. Like literally, it's $100 to touch a drive on that list or something. So email and eBay is still going to be your cheapest cost for getting donors, but you need to email all of those people and you need to be friendly with those people. Not all of them are friendly back. But try to be as friendly as I can and try to find a working relationship with some of these people. And if you can get off of eBay, sometimes they'll give you a better price because they're losing money selling eBay and PayPal. They lose 7%. So altogether, they lose 3.5% or 3% or something to eBay and another 3 or 4% to PayPal. So if you can make friends with them and then email them or call them, then you can do a better job. So don't forget in all the other settings. Now, I've been over this. We've been over it a couple of times. Sometimes just different settings can get you a data recovery to work. And so this doesn't have to be done necessarily. There are times you can use free software. Linux is going to be your best choice if you want to spend a lot of time learning how to do it. You can switch all of the things that we've been doing on a deep spar, so you can go from DMA mode to PIO mode on the fly. You can change from LBA 28-bit mode to 48-bit mode, and some people don't realize that even in Windows still has, just as a secondary note to kind of show you, people kind of forget that these things happen, but no, I was going to say, so this was something that was added in Windows 95. It's still there. It's still in Windows 7. It's still in Windows 10. When you get to the IDE controllers and you look at the IDE controllers, if you cannot do it on a primary controller, you can only do this on a secondary controller. So on a secondary controller inside of a machine, if you have a secondary controller, which you always do have a secondary, because the primary is just the one Windows is booted on. In the secondary controllers, you can plug up an extra drive, and you can unplug and plug them on the fly. And so you can pull the tree, you can say pull the tree and scan for new hardware. It will add the drives in. Well, here, what people don't realize is that you had control under advanced settings to convert back to PIO mode. So if you have a secondary controller and you had no other hardware, it is possible that you could just use Windows and go back to PIO mode on a secondary controller and do a recovery better than you would have done it through DMA. DMA is a huge problem a lot of times. It's memory that's a nickel that they just get from the cheapest provider that's possible sometimes for them to transfer content across the bus. So this is an option. You don't have a lot of options here, but you can also make your hard drive go to sleep. I can do a hot swap live on a Windows machine. So now here's the thing, you don't have a lot of control here. What you have is a power option. So if you go to your power settings, there's well, I'm getting old maybe. There is a power setting that you can do that says go to sleep in 3 minutes. So you can set your hard drive, and that's the lowest number you can set it to is 3 minutes. So you can tell you want your hard drive to go to sleep in 3 minutes and walk away. So you put that setting on, go have coffee, and come back, leaving the secondary controller alive, and you'll hear it. And it happens now even to you that if you have 2 hard drives in your computer and you walk up, I know people do this all the time. They'll touch the computer, you hear the second hard drive spin up, and you'll be like, hurry up, I'm trying to get into my D drive. You'll see it. And sometimes the other thing is people don't realize is when you're looking at your list, and I'm in the C drive, so your D drive would come up, even if it's asleep. You might have this list running and your drive goes to sleep. And you walk up and you click on something and it takes a couple of seconds. All of a sudden it'll be like you can hear your drive spinning up, and then the directory structure refreshes. Have you ever seen that happen? So here's what's happening. The hard drive went to sleep. It left everything alive in memory on the drive, even the directory structure that was previously loaded. However, when you touch the drive and it spins back up, it refreshes the directory structure listing and rereads the root of the drive's table. So you could have a completely different hard drive and your directory structure will change right before your eyes. So if you took a hot swap on a drive, you hooked it up, this original drive was a good drive and it was formatted with a folder on it that said I am the man, then as soon as you switched it to the other drive that had a directory structure for your client stuff in the hot swap process, it will refresh and you'll see the entire folder structure just come back. You'll be able to then select folders and get them off. Does that make sense? So that's happening already. People just didn't realize that that's what's happening, is it reloads the user area on the fly after it comes back from sleep. It doesn't reload the rest of the stuff. It doesn't reload serial number, model number. You have to tell it specifically. There's a command for that. That would be a reinit command. But it doesn't happen by default unless the drive fails. If the drive fails, it does a reinit. So everybody good so far? So I think those are cool things. Those are things that a lot of people that I talk to that have been IT people for a long time don't know why they happen until I explain that. But that's what's going on. Never, ever, ever let any of the tools to rebuild the drive do that on your original drive. If you ever let that happen, you're losing data. There's no good point about that whatsoever. So make sure that you never ever let check disk, scan disk, any of these other things run or do anything. Now we'll talk about the Seagate diagnostics port when we get to it, but basically you can buy a $25 cable. Even if you don't buy any of the other tools, the $25 cable you can just use with a modem tool, hyperterminal or something else that's still in your software, and you can see the Seagate respond to you. It'll tell you what's going on. Most of the other drives don't do that, but they do sometimes have serial ports for diagnostics on them that the PC3000 and other tools take advantage of. But Seagate's the primary one that lets you see through the diagnostics terminal what's going on. Okay. And then the other thing, the note that I have here about other operating systems mounting stuff, we're actually going to get in a deep discussion about this in a few minutes, but it has to do with the tables and that you're running a different piece of code. And I'll show you what happens because we're going to get into that. I would think I never had to say that. I swear to God this has happened. Like a guy needed his PST file back. He accidentally deleted it. He starts to do the recovery, but he wants it on the same drive, so he rewrites his PST file back to the same drive. So the recovery software is writing to the local drive, so it's chasing itself like I'm recovering the file that I'm writing to the same hole that just deleted it. So I'm filling in the hole that I'm recovering with the same file. So, because Windows will look at it and say, well, what's the first big hole that I have? Oh, look, he deleted PST file. There's a chunk there. Let's use that. And he overwrites the file with the same file. Lawyers do this stuff all the time. Lawyers do not know anything about IT, but they think they do. And so the evidence box came in, and it was sealed with evidence tape. But I wanted to see if that spreadsheet was on that drive, exactly like my client said. So I pulled it out and plugged it in. I didn't make any changes. I just opened up the Excel file and looked at it. Really? Man. All right, so never boot the system that you're trying to recover from. People keep doing it. Well, it was booting, but now it's not. Now every time I boot it, it says NT loader not found, and then boom, it didn't work anymore. I didn't even get NT loader anymore. So things like that happen. Don't do that. So I have a process because of business. I do not erase the original drive I was using. So even though I'm swapping these drives and doing this, I'm marrying these two drives together. So when they come in, the drive comes from the client. It's all labeled and Xeroxed and all the stuff I told you before. And then it's processed on a computer. Now I have a clone of that I've now made on a DeepSpar, Tola, PC3000, repaired. These go together now. And so the original drive is labeled with the label. Mine is just married to it. I don't keep putting labels on them. That goes with it to the logical side. Now I recover the Windows stuff and I write that somewhere. I have a server and I write data to that. I make a client folder. So I have a number that goes on the original client stuff, so it has a sequence number. So 10,247, Sony, blah, 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 whoever it is. Like sometimes I have the different departments, so I have to have multiple entries. When I write that to the server, it'll be 10,293, whatever it is, dash Sony, and then I write that directory structure exactly the way it came off of the drive to that folder on the server. So now these two are going together. Now I'm done. Client says, I want my recovery. Buy a drive, send me a drive. I don't care what happens. Sometimes if it's a RAID array, they've got to buy a whole RAID array and send me a RAID array, and it takes a week. So once I have filled that drive with the data, I box that back up, and I usually take the original drive and their new copy and leave my copy of their data, and I'll take the sticker and move it, and now this sticker now stays on the shelf of currently recovered items that are mailed. So now the original drive and the client data go out the door to the client. And 2 weeks later, if they don't have it, we have a problem. FedEx got hit by another truck and it's out in the middle of the street somewhere. So that now I've got a copy, because if your copy never gets to the client, you never get paid. Even if you've already charged a credit card, whatever else happens, they'll argue it. I'm not going to, and if you don't have a copy, then you don't have anything to give to them. Now in theory, I have two copies depending upon what the situation is. I have the logical copy I wrote to the server, and I have the clone in case I need to go back to it for any reason. So I've got 2 copies. If it's a forensics case, I also have 2 copies, but now I have a copy that has an in-case file that's on it, and they're together, they're not on the server. That's a forensics case, so I don't write that to the server. Does that make sense? So those 2 go together. So that way I cover myself in the shipping process. If you are shipping anything and it's the one of a kind, trust me when I say that's a bad scenario. You want to make sure there's a copy before it goes out. You can destroy the copy 2 weeks later once they got it and that they've confirmed that they got it, even if it's for a case. You want to make sure there's a backup before it goes out the door. Okay? So that's how I'll treat it from that standpoint. There's a tool called MyHardDrive that can read HFS and APFS. And it adds a driver into Windows that will then allow you to use a Windows system to read Macs. And surprisingly, it's great for HFS. HFS gets corruption in the tree all the time that apples themselves cannot fix. Surprisingly, for some reason, MyHardDrive can mount those. It will ask you, do you want to repair it? Always say no. MyHardDrive has never successfully repaired one. But if I say mount it, I may not get all of the folders, but I may get the users folder where 90% of the data is, and then I can actually read that data from a Windows machine. So where a Mac could never have done it. So I'm just telling you, MyHardDrive is a great tool for like 70 bucks. Adds the HFS and APFS drivers into your system. Paragon also has a APFS driver, which we've had to resort to sometimes to actually be able to mount something and look at it. RStudios now does APFS and does the encryption key in RStudios. So RStudio now has, in the newest version for APFS, the ability to put in the passwords for the encryption and decrypt it in the fly in the data recovery software without doing it in hardware prior to that. So that's kind of nice. It's an option though. It's hidden in an option screen. So you have to know where it is in order to turn it on. So just keep those things in mind. But MyHardDrive, if you set it to read only so that it doesn't modify the disk, it makes you reboot the machine. That's why I say to turn it on first, because it'll force you to reboot, and you don't want to do the repair. You only want to get the recovery back. So Tim, it's a great tool. You will love it for HFS because that would be the first thing I would probably try for a drive that might not be reading after I've imaged it, if I can image it, is plug it into a Windows machine with MyHardDrive on it. Even if you think, oh, well, this is a Mac, and Mac should be able to read their own disks, there's a disk arbitration problem. And trust me when I tell you, Macs cannot. They do a terrible job of rereading their own disks or damaged disks. So MyHardDrive is actually a hokey piece of software, but it works great. So, all right, and then you need a backup. And there's nothing worse than telling your client, I've got your recovery done, here's a list, and then your server dies. That's about as bad as it can get. And then you can't get their data back. They may blame you and sue you. They're like, oh, you have my data, but you lost it. Oh. So, and I've had court cases where that happened before, where they've recovered data from a dead server that was used in a criminal case, and then they chose to erase it for some reason. There's a whole discussion. It's actually been testified about in court, and they did it like 3 times actually. Like they actually recovered it and then lost it again, and then recovered it and then lost it again, and it was deemed bad faith on the part of the police, and the case was thrown out. So anyway, all right, so in this process, the next portion of this, we're going to start heading into file systems and what we're actually looking at as far as the data. And the big deal is trying to identify the file system that you're working with. And I've showed you some ways, like you could hit home key, you can go hit F3, you can look at the partition structure. But you also sometimes, if you've lost the partition structure or GPT, you've got to go scan for the strings that would start the file system's directory structure. So NTFS has a string, and every OS has a basic process for how the partition structure starts, and you have to find that location. The hardest ones to do are Linux. Linux is the hardest ones to find because you need the block cylinder groups table in order to find the location, but they're redundant, so they are there somewhere. So all right, we've already talked about DeepSpar. Like, we've spent a lot of time on DeepSpar and showing you some stuff. I'm going to skip this part for now. We'll come back to it as a whole in the data function. So I want to talk about partitions. We are on page, we're in book 2 on page, what page again? 17. Thank you. All right, so we're still going under the premise that everything that we're dealing with is 512 bytes. It's not really true that it's 512 bytes today. We've been starting to make some changes. But logically, for the most part, things that are a different size are being broken out for you in 512 byte sectors. We're going to talk about these things now because they are important and what happens and where are we going. So the MBR exists even in GPT. GPT is a file, new partition format that was not supposed to be dependent upon the MBR, but accidentally was tied back to the MBR. And so now it cannot easily be separated. Even Windows machines that use GPT, if the first sector is damaged and 55AA is not there, it generally will not mount the disk at all. It'll look exactly the same as I showed you before. You get the red circle, non-initialized, Windows won't mount it. So the MBR is normally going to be 4 primary partitions, so those 4 positions that we've already talked about, or you can have 3 primary partitions and 1 extended partition, and then an extended partition can be wrapped over and over and over again. I've seen 72. And then there's a possibility of GUID partition tables at 128 partitions. Now, I've never seen anybody try to do that. There was more partitions actually in older days on individual drives than there is today. Before, when everything was 32 gigs or smaller, if you needed to have a bigger hard drive, everything was limited to 32 gigs in Windows 95. So up to that point, that you just had to have multiple disks, multiple drive letters. We don't have that hardly today unless you're running multiple operating systems, Linux and so on and so on. So this is fundamentally how it started out. The data that was inside of the MBR was originally cylinders, heads, and sectors. When they upgraded basically the to LBA 28-bit mode, which is what we've been using at least since 96, 95, something in that range, they took those and converted the space, the same layout, and the same content, they had 32 bits. So what they have now in the table is the file system, is it active, is it the bootable one, and then they have 32 bits that says where is the beginning of my partition and how big is my partition. That's the primary details you have there. Now you don't need to sit here and decode all this all the time. It doesn't make much difference. Most of the time, the majority of the time, from where the partition starts, it is the end of the disk. Most people have a single partition and it's usually the end of the disk. So if I had to guess and I didn't have a partition table correct, I would say, where's the string start? It says NTFS or the file system or whatever, and then go from there to the end of the disk. And primarily, most of the time, unless it's a server, it's a single partition. So with 32 bits, we can only go to 2 terabyte as a partition. We had this discussion the other day, right? So it's 4 billion something something. You divide by 2. You can only have 2 terabytes in an MBR as a partition size. Doesn't matter if you're on a Mac, if you're on Windows, if you're on anything. The Mac ignores a lot of that stuff after you get past that. So Macs now don't have that limitation because they're not using the MBR. In 2006, they upgraded and the Mac ignores the MBR and automatically uses GPT. And they have used GPT since 2006. They are the first commercial operating system using GPT. It started in 2004 by Intel. Started the GPT structure. Originally it was a paid licensed thing, and then when they got to version 1.1 they made it open source basically and gave it to everybody, and that was probably because of Apple, because Apple wanted to switch their processor from a Motorola to a Intel processor, and there's a reason for that too. But alright, so here's the whole point that I'm trying to get to when we're talking about partitions. Now, on partitions, this is a real definition that comes from FDisk in DOS, all the way back to 1982. All partitions must begin on a cylinder boundary. Now, we're on LBA blocks, and even though LBA is a combination of things from cylinder boundaries, LBA blocks should not need to worry about a cylinder boundary. Does that make sense to people? Because the cylinder boundary is the picture from the first book. So on this picture right here, remember I told you on day one, when we start looking at the disk, there were some design specs that happened that were done inside of this drive. They were still carrying forward. Legacy material were carrying forward. So imagine back in the day, you've got a drive and you needed to find a partition. If your partition could, because everything went down through cylinders, right? So you write to the first location, you turn off the head, you write to the second location, you turn off the head, you write to the third location, and so on down through the stack. So you stored your data in cylinders. Everybody good so far? So if you had a partition and you wanted to go from drive C to drive D, if the partition could exist anywhere, then you'd have to look for or switch to that head for that partition wherever it is. So if it could randomly be anywhere, you would go, oh, are you a partition? Nope. Are you a partition? Nope. Are you a partition? Nope. Are you a partition? And it would have to keep doing that till it found its location on the drive. Now, we could have some information in the MBR that takes us there, but it still takes a lot of time on old hard drives. Remember, these things, we're in 3, 4, 6 milliseconds now for blocks. Back then, it was probably 100 milliseconds for just to get there. I mean, it was probably a really long time. Really slow drive by comparison to today's technology. So, Microsoft is given this choice. Hey, here's what your drive looks like. Microsoft did not make the hardware, right? They're given the hardware and told to make something work. So, the issue is, how do you deal with a partition? So they made a decision that a partition could only begin on one side of one disk. All partitions on your entire drive will only begin on one side of one platter. You understand what I'm saying? And the advantage is, if it always is on one side of one platter and I need to switch to a partition from drive C to drive D, what's my advantage if it's on one side of one platter?
You don't have to switch heads?
I don't have to turn off the head. So I do not have to switch heads. I have no head latency. And so there's a finite number of them. So there's 263 tracks. So I can only have 263 possible locations for a partition, but you also are eliminating the last one. So you're eliminating, if I have a partition, it can't end and then start on the next partition boundary so that there's no space in between that's used. There always is a gap between the end of one partition and its cylinder to start on the next partition on a next cylinder. And once we got to LBA 28-bit, we emulated that. We made that happen so that all the legacy software and equipment that we had would work. If you can imagine, you're Norton Utilities, and you wrote a tool to Norton to fix your hard drive and to keep track of your hard drive. Everybody ran Norton back in the day. I'm not kidding you. Norton Utilities was, if you didn't have that, you couldn't keep the health of your drive up, you couldn't defrag your drive, there was all kinds of things you couldn't do. That was like the best set of utilities that ever existed back in the day. So you had this hard drive, and then from then up until the mid-90s, before we switched to LBA 28-bit mode, if you made a change to the hard drive, you had no way of telling everyone, don't run this software. You couldn't stop them from running that software. So if you gave somebody a new change to LBA 28-bit mode, and then you ran Norton Utilities on it, it would eat your disk. It would eat all your data. So for a legacy reason, they made a choice that when we went to LBA 28-bit mode, we're going to pretend it's all CHS. So we came up with the numbers for CHS, and now your partition must have begun on a cylinder boundary, even though it's a logical cylinder boundary. So it may not actually be on one side of a platter when we got to later drives, but it was the same calculation as the original calculation for the location. Does this make sense to everybody? So it was all about speed, trying to make sure that we could switch from one partition to another without turning off a head. And then we carried that forward in the legacy stuff, because until the internet came out, there was no way to stop people or tell people, don't do this, a bad thing will happen. How are we going to give you support? Everybody's going to pick up a phone and call us. So they made it all for legacy. And then because that legacy started before the internet started, so from a date standpoint, again, some of you may not be old enough. I lived in a day when there was no internet. And so 1990, actually I did play on ARPANET before it was the internet, but 1993 was basically when it became a public kind of utility, and that you could now add in and use the internet. Tim Berners-Lee wrote the hypertext basic premise for web browsers, and that we ended up with a web browser from that point forward, so we could actually then go look at stuff. And then Google and everybody else comes along with finally having an index of all those things. Before that, we had to know what it is that we were going to. So nothing really happened until about 96. 96 was kind of where things started to blow up a little bit. We started getting servers and more websites and things like that, but we still didn't have good data until 2000 or 2001. And by that time, XP came out. And then XP is pretty much their longest living operating system, so there was still no way for them to do certain things to tell you about things that they were going to not be able to use on your system based on legacy performance. But we had LBA 28-bit mode until 2001, something in that range, so we were kind of okay with all the legacy stuff that had happened at that point. So the design of the drive is all based on the layout of the data on the drive, and you could point to it. You could actually say, I know where my data is and what side of the platter it's on and how it was written. So this was a piece that lived until Vista was born. This piece said you cannot have a partition that does not begin on a cylinder boundary ever until Vista came along. And that also means that between the end of one partition and the beginning of another partition is 8 megs of unusable space. There's called a partition gap. Every forensics class has that whole, this is where the bad guy hides his data because it's available to him to use and he can write something there, but it's not available for the partition, so it sits in between two partitions. So there's 8 megs of unavailable space in between two partitions, because that's the distance of a cylinder boundary. Everybody good so far? So here's your consequences. So here's what happens. When you're looking at a picture of your hard drive. Now this is upside down. When I created this picture, I did it backwards. Because people just see things better this way. If I did it upside down, it wouldn't be quite as obvious. 0 is on the bottom, 1, 2, 3, 4, 6, whatever. So you go through the entire stack. So you have cylinders, and the cylinders intersect all of the platters. So wherever you've got a track and a location, you have cylinders that then cut through the entire disk. Everybody gets so far? So by definition, when you're looking at this, if you always have to have a partition on a cylinder boundary, when you look at a disk, it actually makes logical sense. So the outside edge is the fastest location, right? That's why LBA 0 is on the outside edge. So now you have zones, and a zone is only going to be this long all the way through the disk. So you'll have a ring that will say these zones belong here for speed. So the hard drive's breaking that up. But as far as the operating system is concerned, they're just logical blocks, and the fastest one is the outside edge, and the slowest one's the inside edge, and that's why defrag was created. Defrag is created to move the data that is inconsistent further out on the disk to a location further up on the disk for speed purposes and to make it contiguous so that the head can read it all at once. Does that make sense? So the first partition must begin near the beginning of the disk, because that's where all of your stuff is going to happen. Your partition is going to be created, your MFT tables are going to sit here, your FAT tables are going to sit here. Everything's at the beginning of the disk. That is also the fastest location on the disk. So all those dates and times and things that change get written to faster than the data that's further out on the disk. So if that's the layout of the disk, what do you know about the second partition by default? Where is the second partition? If I make a second partition on a hard drive, where is it? What?
Same platter further in.
Yeah, now it doesn't have to, like, since we have LBA, we don't have to worry about the platter. Wherever the calculation is just logical now, and it's still CHS. We just don't know where it might be because manufacturer can change the zone tables and put it wherever they want. So it's logical to us now. So we took a physical thing and made it logical. But it's further into the disk. So if your first partition is here, and you make a second partition, then you are mapping out however much data that there is between here and there in the zones all the way through the drive. So if I say I want my first partition to be 32 gigs, then it starts here. I have 32 gigs throughout all of these platters because of zones and speed. Then the second partition is going to begin right here, right? What inherently is different about the second partition than the first partition?
Size of the spin.
Which?
Slower?
It's going to be slower, right? So the effect of that is that it's slower. So the second partition, by nature, by the creation of it, is slower than your first partition on any drive. By default, right? So same thing on Macs, same thing on Windows, same thing on Linux, same thing on RAID arrays, same thing on servers. If it is the second partition, it will be further into the disk, and by its nature, it will be slower than the first partition on the disk. So Boot Camp, how does Boot Camp work on a Mac? Anybody use a Mac at all? Or what does Boot Camp do?
You can make dual boots. Or
Right, you can make a dual boot system out of a Mac. You can make it run Windows. Do you do this?
No.
So, because you just don't like Windows, right? Like,
We have separate Windows machines.
okay. So, so if you have a partition that you want to create and you want to put Windows on it, what it does is, do you guys remember a tool called Partition Magic? Anybody remember this tool? Yeah, so Partition Magic was amazing back in the day because before Vista and all these other things with Linux and stuff came out where you wanted to do dual boots, you wanted to have separate partitions, there wasn't anything. Partition Magic was it. And what Partition Magic did was this. You had an MBR, and it was here, and it had 32 bits of data pointed to a location. Well, if your one partition was the whole disk, you basically had to, before Partition Magic, copy everything off you wanted, reformat your disk, redo the partitions the size that you wanted, and then copy them back to where they were. So you had to do all that manually. There was no way around it. So Partition Magic, what it did was it said, all right, listen, I know that you've got 4 entries that you can have, so I'm going to give you one of those entries. And what I'm going to do is I'm going to go to the end of the disk, and I'm going to say, all right, I want to create another partition that's 32 gigs. So it will go to the end of the disk, and it'll say, all right, I'm going to come backwards 32 gigs. I find 32 gigs from the end of the last LBA. I defrag that. I pick up all of the files, and as long as you've got enough free space in the beginning, I'll pick up all the files, and I'll move them to the first one. So once I have all the stuff in the beginning of the disk, and I've got that last 32 gigs free, it doesn't erase it, it just moves it. And then I have 32 gigs. Now, it doesn't actually write anything here till you formatted it and create it. It comes back to the table in the MBR and says, now I have a second partition, and the partition begins there. Now I have to format it, and then that writes the NTFS or FAT or whatever table that you have and puts it there in another partition at that end. And then from then on, you now have a new partition that has been added, and you can now use that for storage and have a D drive or whatever drive letter you want. They were hard-coded in the beginning. Later on, they were virtual. You can make them whatever letter that you needed them to be. So whatever you just created was now slower. So Macs put Windows in the slowest part of the disk by default. So that's literally what they do. They just say, oh, okay, well, I'll give you some over here. And it chunks it out from the back of the drive and puts Windows on there as a boot drive. And Linux and everybody else, they're all the same kind of thing. They're all going to be in order. So now, if I'm a person managing databases, servers, Exchange server, any of those things, this is an IT thing that these guys do not know, and I did managed IT services for 18 years. And the first thing that I would do when I walk into a company to try to prove to them I'm valuable, contract me, I'd be like, I can make your server faster. They were all having problems with stability, how fast is my server, I can't do things as, my databases aren't running as fast as I want them to run, my accounting server is slow. how do I solve these problems? So the very first thing I would do is I'd come in and I'd say, all right, you have a RAID array, and you have 4 of these. It doesn't matter how many of these drives I have. The same thing happens on a RAID array. The LBA blocks start out here, and if you have a 64 gig partition, then it's just spread across all of the drives. But it's still the outside edge of the drive. It uses LBA blocks in the same way. They're just merged together across it in a logical fashion. So now I have one strip that is a partition like this. I have a second strip that's the next partition. Because on most servers, there's 4 partitions. That's the majority of them. They would buy Microsoft Small Business. They would buy the whole set of Microsoft Server, Exchange Server, SQL Server, and then they needed regular functions for the users. They needed a user storage location, and then they almost always had another one, which was, where do I put my software that I'm going to install on all these people's machines? They keep ISOs on the server, and then they would just run to people's machines and install stuff, or keep this software there. Does that make sense to everybody? So if you're looking at it from that perspective, you can make your server faster by relocating all of the data. Because when they first installed it, this is what every IT guy does. Well, I need the operating system. So I create the first partition, and I give it 40 gigs, 100 gigs. And then the second partition is going to be the ISOs and the user files that I wanted to put on my disk so that I could write this to everybody's stuff. The third one's going to be the users, so he can start creating users and get them set up. And then as an afterthought, the last one, the next one's probably going to be Exchange Server, and then the next one's going to be SQL Server. The things that you write to the most are SQL Server and Exchange Server. The Exchange Server never stops. It just constantly writes all the time. Reads, writes, all day long, recreates its database, defrags its database all day long. That's all it ever does. SQL Server is direct transactions. Somebody's entering accounting software, and they're typing something, and it's immediately storing. You can see the effect right away. So the IT guy put the 2 things that needed to be read and written the most in the center of the disk. I can improve performance 18 to 20% by taking that partition and imaging the partition and writing it over the first partition. So you can literally back up your server in all those partitions individually, recreate the structure for your partitions, re-image back all of those sections and put them in a different order. And the server will boot. You don't have to change anything else. You just image it and restore it, and then tell the C drive it's the center of the disk instead of the outside edge of the disk, and it will boot and run, and you can reorder everything. So if you're working on anything that you're dealing with a disk, it really matters to think about the layout of this. If you want the fastest possible way, think about the order of how you're doing it. It doesn't have to be. When you first start installing your OS, you don't have to install it in the first partition. You can stop it, create 4 partitions, and install it in the last partition. So you can make those choices today from a speed standpoint. But your partitions are all going to be on what it calls cylinder boundaries. There's going to be gaps between them, and we're going to have a lot of legacy stuff that we're carrying forward. But speed in the partition process is very important. The reason I'm bringing this up is not because just to tell you how to make your system faster or to make it do something else. I mean, it's pretty important to understand the physical layout as you start looking at it. When you start looking at your physical disk and you're doing a recovery, you'll know I have 3 partitions, and as you go through 3 partitions, they are 3 physical partitions divided up on that pie. So you get the outside edge, will be your Windows, and your inside edge will be whatever the last partition contained in that process. So when it had to begin on cylinder boundaries and all of this was all code, then we had this process by which when we had hard drives that it always had to do this calculation on a 512 byte boundary, and it always were individual sectors and then those sectors aligned. So you always had a location for 512 bytes for a sector, for a cylinder and a partition. Everybody good? Here's where it goes wrong. So in 2010, now this was going on for possibly 3 or 4 years. They had drives they did not release because they were afraid to release them to us because Vista came out, and Vista is the one that made the changes. So all of this other stuff was all static, all the way up through Windows 2000, 2003 Server, 2008. Vista is the one that messed everything up. They said, okay, well, Vista, we're going to get rid of all this legacy stuff, and we're going to start trying to move to a new type of technology, and we're going to get rid of all of our old legacy stuff, And because now we have the ability in our OS to stop programs from running. If you try to run Norton now, it'll say, oh, you can't run this. I'm sorry. And the operating system will actually intercede. It'll even sometimes look up stuff on the internet and say, oh, this one's obsolete, can't use this tool. I'm not going to add it. They took a bunch of them away. There's a bunch that no longer run at all. So, and Partition Magic's one of those. So, when you're looking at new drives, so these started coming around 2010.